Good morning, fourth grade. Today we're going to do Module 4, Lesson 13 in Geometry, and we will be classifying triangles by their attributes. That's a very fancy way of saying we're going to sort our triangles by their side length and their angle measures. First of all, you're going to need your templates, and we're going to have all three of the templates for the triangles, and then we're going to have our recording sheet, which was where we're going to record our responses. So we're going to start with a sketch. If you take a look at the first part of your template, it says to sketch the triangle. So when you sketch, you're not going to use a ruler. You're not going to measure. So when I take a look at triangle A, which can also be called triangle XYZ, okay, because of the letters in the corners of the angles, all right? When we look at it, we notice that all of the sides are about the same. So I'm going to do my best with my finger to draw all of these sides about the same. And no matter how many times I tried, it's a little bit off. But it's a sketch. It's not an exact duplicate. So give yourself some grace. So one of the things we noticed is that the side lengths has 3 sides. I'm going to make mine a little bit bigger with the same length. We have a fancy name for that, which I'll give you in just a minute, because that's what we're going to write over here. Okay? The other thing I notice is in the angles, I have 3 angles that are about the same measure. I'm going to use the little symbol for degrees here rather than trying to fit the word measure in there. So they're about the same degrees. Now, in our classification, we have special names for these. So we're going to be classifying by their attributes, which are the side length, okay, and the angle measure. Fix that A. All right, so when we look at the 3 sides being the same length and all 3 angles being the same, we have what's called an equilateral triangle. So write that in your box. So one of the special things about an equilateral triangle, in order for all of the sides to be the same length, all of the angles will always be acute. And you have already learned that an acute angle is an angle that is less than 90 degrees. And when you look at triangle A, you can see that all of these are less than 90 degrees. You can see that at a glance. So we would say that triangle A is an acute equilateral triangle. An acute equilateral triangle. So we sometimes name the angles first. All right, let's take a look at B. So I'm going to scoot this up to B, make it a little bit bigger. This is triangle B. It is similar to triangle A in that all of its angles are acute. Since we noticed that right away, I'm going to go ahead and write that in over here right now. but it is not an equilateral triangle because all three of the sides are not the same length. So let's sketch it really quick. Go ahead and sketch it in your space for B. Pretty close. Even though it doesn't have three sides that are the same length, it has two sides that are the same length. So I'm going to write that in my chart. And I'm still going to add the other attribute of 3 acute angles. And I'm going to use my little symbol for angles. 3 acute angles. Okay, so we have a special name for a triangle that has 3 acute angles but is not an equilateral. It has only 2 sides that are the same length. And we call that an isosceles triangle. And that's what we're going to write in this chart. Isosceles. Huge word. Isosceles. Isosceles. Say that with me. Isosceles. Say equilateral with me. Equilateral. Say isosceles with me one more time. Isosceles. All right. So we would say that this is an acute isosceles triangle. Triangle B is an acute isosceles triangle. All right, we're going to go back up to the first template for the triangles and take a look at C. Oh my goodness, this is not an acute triangle. We totally know that. So we're going to try to draw that. I'm going to make this a little bit bigger, give me a little more room. Try to sketch triangle C. And I missed the letter inside. Okay. All right. So we know that that is not an acute triangle because it has one angle that is not acute. Even though it has 2 acute angles, it has one that is not. So it is not an acute triangle. Because it has one angle that is greater than 90 degrees, we're going to call it an obtuse triangle. So it has one obtuse angle. Any triangle that has one obtuse angle will automatically have 2 acute angles, but because it has one obtuse angle, it is called an obtuse triangle. So I'm going to go back to my attributes here and say it has one obtuse angle. It also has 2 acute angles. But the obtuse one is where it gets its name. Okay? Now, if we had a ruler and we were to measure these sides, we would see that all 3 of the sides are different lengths. So it has 3 different, be sure you're filling this out, different side lengths. Okay? We have another big name for that. Any triangle that has 3 different side lengths is called a scalene triangle. Scalene. A scalene triangle. So this one, triangle C, is an obtuse scalene triangle. Okay, let's take a look at D. Let's go find D. Ooh, Look at D. What would you say about D? Let's try to sketch it first. What would you say about D? It has one right angle and it has two acute angles. Okay. What about the side lengths? You can probably estimate that it has 3 different side lengths. Okay, so what have we learned about 3 different side lengths? Yes, this is a scalene triangle, but it does not have an obtuse angle. It has a right angle, and so this is a right triangle. So we have a right scalene triangle, or you can say it's a scalene right triangle. Scalene tells you that the lengths of the sides are all different lengths, and right triangle tells you that it has one right angle. Okay, what's different between that and E? Let's try and draw E really quick. Sketch it. Okay, well, you might have said it has one right angle and two acute angles, which is just like the one above. But what is different about it? And you are right. It has 2 side lengths the same. Okay, so this one, there are no more new words. We're just going to use the ones we have. What did we call a triangle with 2 side lengths the same? That's right, isosceles. So write that in. And it has one right angle. So it is a right triangle. So this is an isosceles right triangle, or a right isosceles triangle. We only have one more. We're going to take a quick look at that, and then I'm going to set you free. Take a look at this one, F. Again, we're looking at 2 side lengths about the same, but it is an obtuse angle, isn't it? Let's try to draw that. And I am way off. Okay, but again, it's just a sketch. So it has one obtuse angle and 2 acute angles. And it has 2 side lengths the same. Okay, if it has an obtuse angle in it, what kind of a triangle is it? It is an obtuse triangle, that is right. And if it has two side lengths that are the same, what do we call it? That is right, it is isosceles. Okay, so your triangles are either going to be change that color, sorry, are either going to be equilateral and acute, or they're going to be isosceles and acute, or they can be scalene and acute. We did not have one of those here today. Or they can have different side lengths, all different size, and be scalene. And by angles, they can be obtuse or right or acute. So when you classify your triangles, you're looking at the length of the sides and the size of the angles, whether they are smaller than 90 degrees, which is acute, larger than 90 degrees, which is obtuse, or if they are exactly 90 degrees, which is a right triangle. All right, as you do your problem set today, you're going to select equilateral, isosceles, scalene, and you're going to select acute, right, and obtuse. Be sure each time that a question asks you to classify a triangle that you fill in both classifications, okay? And on one part of your problem set, it's asking you to name the triangle after you draw it. So you're going to need to use the symbol. Let me change this to a pen here. The symbol for a triangle and the letters of the vertices. All right? Be sure to turn your work in on Thursday. Bye.